Okay, so we've got more discussion about radio waves, where we've made radio waves visible using this pink color that I've picked that has decreased opacity. And so we have transceiver 1 by itself. It's shining energy up, and we're having it hit this piece of steel. And what we've demonstrated here is something that's not exactly what would happen. This radio energy is not going to penetrate metal. So we should really turn that off and turn this on, because this is true. The radio energy from transceiver 1 by itself would come up here, run into this piece of metal. You'll notice that I've got the ceramic in there. Okay, so it's shining into a hole filled with ceramic. And what would really happen is not quite exactly this situation, because where there is ceramic and a hole in the metal, you can have some penetration of radio energy. So we'll put the pencil beam in there. And so now you see that the radio frequency energy went along, ran into a obstruction of a material that is opaque to radio frequency, and it stopped it, except for this one little spot here where there's ceramic, and it shined right through the ceramic and came out on the other side and hit this transceiver. And so the an opening that you place in a piece of metal can alter the nature of the radio beam that is propagating itself through the air. So this radio beam that has this shape, has this footprint, this big, turns into a radio beam that looks like this. And again, remembering this, actually in this drawing, if this was really air, this would be one of those hemisphere things, but we're not going to get into that. What we're trying to show is you can alter the magnitude of a radio beam property by putting something there that restricts it. Now, similarly, we can go over here and make a radio transceiver in a device that's creating or making the radio transceiver generate its output, and the radio transceiver generates its output, and you can surround the radio transceiver with a material like metal that is does not transmit the radio energy. And so the radio energy, instead of coming out as that giant sphere, comes out in this cone-shaped distribution. And one of the things that would cross your mind is that as you put a structure in front of this transceiver that limits how much radio frequency energy can be transmitted, which would be the equivalent of making this hole smaller and smaller and smaller, the assumption that you might make would be that as you made this hole smaller and smaller and smaller, that this little cone would get smaller and smaller and smaller and smaller, and it would be less and less and less output. And one of the points that needs to be made about this concept of this cone getting smaller and smaller and smaller and less and less and less as the obstruction becomes more and more and more is that actually quantum mechanical problems kick in, and the cone that is being created converts itself, and I've magnified its size, but it converts itself into a cone where there's areas of energy and there's areas where there isn't energy. And so if you made an obstruction of the output of the transceiver such that the obstruction was enough of an obstruction so there was very little space for the radio energy to go through, it would begin to be diffracted. And what would happen is you would have bands of radio energy interposed with bands of no radio energy. And if the receiving transceiver was looking or receiving this energy, it would have places where there was received energy hitting this transceiver right here, and there would be places where received energy are not hitting this transceiver. And this transceiver circuitry averages or collates together all that it receives, and so it is going to not notice these bands. What it's going to notice is that there's very little energy, and it is possible that it may not pick up any energy.